Hi, this is SM and welcome to my channel Concept of Mechanical Engineering. In the previous class, we have seen the marks distribution of thermodynamics in two big examinations like GATE and ESE, and then we have seen the aim of thermodynamics, which is to convert the low grade form of energy into high grade form of energy in an efficient manner. Then we have seen the basic definition of thermodynamics like system, surrounding, universe, boundary, and we have also seen the types of system, which are open system, that is also called as flow system, closed system, non-flow system, and isolated system. Now we will study the approach of thermodynamics. So there are two approaches of thermodynamics, that is macroscopic and microscopic approach of thermodynamics. So let's start with first microscopic approach. Micro means very small, that is at molecular level. So in macroscopic approach, the behavior of individual molecule is taken into consideration. This approach is also called as statistical approach of thermodynamics, and this approach is used when density is low, that is at a higher altitude. So let us consider this system. So at higher altitude the density is low, that is density rho, that is density is low here. So the behavior of individual molecule can be taken into consideration, and hence this microscopic approach of thermodynamics is applied here. As we go for macroscopic, macro means little big, that is average level. So in macroscopic approach of thermodynamics, the behavior of individual molecule is not taken into consideration, but the average behavior of the molecule is taken into consideration. This approach is also called as classical approach of thermodynamics. So in microscopic approach, individual molecule behavior is taken into consideration, but at macroscopic approach, the average behavior of the molecule is taken into consideration. Now, principle of continuum. So it states that the mean free path is very less compared to the system boundary, hence neglected. So mean free path, what is mean free path? It is the average distance a molecule or particle travels before collision. System is assumed to be continuous throughout. So according to this principle, system is assumed to be continuous throughout, and the behavior of individual molecule is disregarded. It is not considered. So individual behavior is not considered here. Here the average behavior is considered. Now, thermodynamic equilibrium. A system is said to be in thermodynamic equilibrium when it is in thermal equilibrium, that is equality of temperature, that is delta T equal to 0, the temperature is same throughout the system. It should be in mechanical equilibrium, net force and net torques are 0, that is there is a balancing of force and torques, and it should be in chemical equilibrium, that is no chemical reaction taking place. So a system can only be analyzed when it is thermodynamic equilibrium. So to be in thermodynamic equilibrium, a system should have thermal equilibrium, there should be a equality of temperatures, it should be in mechanical equilibrium, net force and net torque should be 0, and it should be in chemical equilibrium, that is no chemical reaction is taking place. Pure substance. A substance is said to be a pure substance when it is homogeneous in chemical composition and it is homogeneous in chemical aggregation. So let us see this, what is homogeneous in chemical composition and homogeneous in chemical aggregations. So let us see an example. A container is there where we have kept H2O2 and H2O. So if we see the ratio of H2O2, 2:1, that is 1:1, and if for H2O, that is water, it is 2:1. So the chemical composition is not same here, it is having different ratio. So this is not having homogeneous in chemical composition, this is not in homogeneous in chemical composition. And if we see for chemical aggregation, see the structure of H2O is this one, and the structure of H2O, this is H2O, or this is H2O2. So the structure of H2O2 is this one, and H2O is this. So here we see that it is not chemically combined in the same way. So chemically combination of these two molecules are different. So it is not in homogeneous in chemical aggregation. Though the chemical combination of these two molecules are different, so it is not in homogeneous chemical aggregation. So since it is not having homogeneous in chemical composition and it is not in homogeneous in chemical aggregation, so this is not a pure substance. To be a pure substance, it must be homogeneous in chemical composition and it must be homogeneous in chemical aggregation. So both the conditions are not fulfilled here, so it is not a pure substance. Other example is H2 plus O. We consider one part and H2O2 the other part. If we see the ratio is same here, 2:1, and in here also 2:1. So it is a homogeneous in chemical composition, but when we see the chemical combination of these two molecules, this is different. This is H2 plus O and this is water. So these are having different chemical combination. So this is not a homogeneous in chemical aggregation. So this is satisfying one condition, that is homogeneous in chemical composition but not homogeneous in chemical aggregation. So it is also not a pure substance. If we consider H2O in steam form and H2O in water form, so this is having the same ratio, that is the chemical composition is same here, but chemical composition is also same here, even the chemical aggregation is same here, because this is having the same chemical combination. This in steam form, in water form, H2O is having the same chemical combination. So it is chemically combined in the same way. So it is fulfilling the first criteria, that is homogeneous in chemical combination, and it is also homogeneous in chemical aggregation. So this is a pure substance. If we see O2 only, then O2 is also a pure substance, because chemically it is same and homogeneous in chemical composition also and homogeneous in chemical aggregation also. Both the condition is fulfilled by this O2, so it is also a pure substance. So steam plus water plus ice, we can consider it as a pure substance, or it is a pure substance. So steam plus water plus ice, these are the forms of water. So this all is having homogeneous in chemical composition, and this is also homogeneous in chemical aggregation. So this is a pure substance. Matter. Anything in space which is having mass and occupy space, that is having size, is known as matter. If we classify matter as pure substance and a mixture, pure substance is further classified as element and compound. Element, it is a pure substance. If we see for element, it is a pure substance that cannot be further changed. That is, it is having a same kind of atom. Example, silver, helium, potassium, sodium. These all are elements. A compound is formed by the combination of two or more atoms that cannot be further changed. Example, H2O, H2O2. This is also a pure substance. If we see mixture can be classified as a homogeneous and heterogeneous. Homogeneous mixture, a mixture with a uniform composition, is called as homogeneous mixture, and heterogeneous mixtures, a mixture with non-uniform composition. So if we see consider a container where we have O2, this black one molecule is O2 and this is blue one molecule is N2. So this can be treated as a pure substance. So though air is not a pure substance, but it can be treated as a pure substance.